All right. Okay, so I guess I want to first see if there's any questions kind of on the second homework, see if there's anything we want to go through there. Any questions ran into? Then once we're through that, we're gonna start getting into logic functions, which is basically like if-then statements. Yeah, basically some different logic and showing you how we put different logical statements together to analyze some stuff. So does anybody guys have any questions on homework 2? Did it go all right? Did everybody do it? Did nobody do it? How did it go? Yeah, no problems?
Some of the functions are kind of annoying to try and figure out. This it was like a star thing underneath, like multiply or divide by 12. And it's kind of annoying sometimes.
Sure.
With that.
Do you want to review any of that stuff? You figure it out, or was it just
Figured it out.
okay? Are we all good on that homework? Nothing to get into. All right. I'm gonna skip and move on. Yeah.
How much of that will be on the Excel exam?
Yeah, so for the MOS certification, like basically, I would like everything I'm not covering any material just to cover it. Like I'm stuff we're going over is very specific to the exam. So everything we're covering will be on the exam. If you look at the class schedule, there's a few Excel items that we're going to cover after the MOS exam. That's because that material isn't on the exam. So everything up until until that exam will be on it. Yeah. All right. Any other questions? No? Good. All right. Okay, cool. Then I get to talk about logic functions, which, to be honest, is like I think where the class actually maybe gets a little interesting. We'll see. I think more interesting than the last stuff. Like making something bold is not that it's very interesting. So we'll see. Maybe you'll like this. So there's a bunch of different logic functions, and we break them down into different classes. And the first logic functions are called Boolean functions. Does anybody know what Boolean means? No? All right. Well, Boolean means yes or no, or 0 or 1. It's discrete. So what it's saying, Boolean functions basically are going to return a true false statement. Okay, so there's 3 different kind of base Boolean functions in Excel. So let's type them rather than write them. So they are and, or, and not. Right. So here's what I'll do. I'm gonna kind of go through yeah.
I don't know if it's the projector or not, but it's like
Oh, that's cool.
Funny. I don't know. It's making it work.
All right.
Sure.
There we go. Let's see where we get here.
Thanks. Sorry.
Oh, that's perfect. All right, start out there. Good. All right, cool. All right, so and not, and or not. And again, they all like have the same flavor, but they're a little bit different. So here's what I'm gonna do. I'm gonna go through and try to I'll do a quick example of each one of these, and then what I'm gonna ask you guys to do is we'll put up like a little short data set and see if you can kind of write a function on your own to do something. So I'll try to go through an example and then throw something your way to see what you can do. So let me just get like 2 columns of data. So we'll just add some numbers. Okay, whatever. So As usual, when we're gonna write a function, we use, the equal sign, then we type and if we click on that, it'll basically give us, or, we see our arguments. So what you can see here is this can take as many arguments as we want. It requires one logical statement, so that's why it says logical. It's because the first argument needs to be a logical statement, but then you can take in as many logical statements as you want. So what does that mean? Well, a logical statement is basically we're asking Excel to do some sort of logical analysis, and they can take the form of a few things. So we could say if C1 equals, if that cell equals 6, this function returns true. So the logical statement that we put in there was we're basically testing if the cell that I selected is equal to 6. And then if it does equal 6, this function returns true. If I put like C1 is equal to 5, it returns false. So it's Boolean, true, false. That's the only thing these functions return. It's true, false. Okay. Now, this is an AND function. So the way an AND function works is I can put in a second statement, and let's say I'm going to test this cell is equal to 8. So I'm basically testing if C1 equals 5 and C2 equals 8, this function will return true. Wait, what did I do? Oh, whoops. I meant to put that equal to 6. Okay, so if C1 equals 6 and C2 equals 8, this should return true. It returns true because both of those statements are true. So again, because we're using the AND function, we're checking basically C1 equal to 6 and C2 equal to 8. If both those things are true, this return is true. If either one of those is not true, it returns false. So again, if I had put C1 is equal to 5, it returns false. If I put C2 equals, if C1 is equal to 5 and C2 is equal to 7, it's false. Okay, so both statements need to be true. Because it's an AND, if I had a third statement, so let's change this back to our C1 equals 6, C2 equals 8, and let's do C3 equals 2. So all those statements are true. So an AND statement, everything has to be true. Change this to like 1, it's false. So and basically we're checking is logical statement 1 true, and logical statement 2, and logical statement. That makes sense? Yeah. Okay. So that's and. You guys. Okay, so that's our and logic. Right? So we're checking the statements, and means they all need to be true. So the next one is or. So if and means if we're checking if C1 equals 6 and C2 equals 8 and C3 equals 1, how do you think or works? Anybody have a guess on how an or function might work? Let me do this. So you see my statement here, right? So this is going to return with an and, because all three of these statements are true, it's going to return true. If I change 1, I'll change this third one so it's not true. The and function returns false. Right? I'm going to rewrite this, but with an or statement. So I'll just copy this. paste it, and I'm gonna change this to an or. Okay, so now I'm checking if C1 equals 6, or C2 equals 8, or C3 equals 1. So the and function, this is false. How many by a show of hands thinks that the or function, and I get it if you guys haven't, I'll catch you up here in a second, so if you're just walked in, you're unsure, it's all right. How many people think the or function here will return true? 1, 2, 3, 4. We got 4. All right, so 4 think true. How many think it will be false? 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 All right, I love it. So that means I can actually ask why. So tell me, why do you think it would be false?
Because C3 does not equal 1.
Okay, so C3 is not equal 1.
The number equals 2.
Okay. So what is the or function checking? Or I'll say this, so what the or function is checking is it's basically looking at all the arguments and saying, is C1 equal to 6, or is C2 equal to 8, or is C3 equal to 1?
Okay, then it's true.
Did I say something? Yeah. There you
I was just
go.
gonna say, like, as long as any one of them is true.
Correct. So the or function, exactly, so with an and function, everything needs to be true to be true. With an or function, one thing needs to be true to be true. Okay, so even though this statement is false, these two are true. So or returns true. Got it? Easy? Okay. All right. That's the case, so. So let's change this to not. So what not is testing. It's basically not is testing, not is like the opposite of and. Not wants everything to be false. If everything's false, not returns true. Which is very confusing. But it's essentially the opposite of and. So in this case. What do you think that this not function will return? Will it return true or false? We've got two statements that are true. We've got two statements that are correct. We've got one statement that is incorrect. You think it's going to return false? Why is that?
Because they all have to be incorrect.
Okay, and we've got two that are true.
Yeah.
Okay, who agrees with that? We'll see. I mean, I know we haven't seen assumptions. But, Oops. No, does not want it to be. I could have written that different, I guess. Well, I guess it only wants me to take one piece of logic. I can write this differently. So what this is looking for is if it's true, it's going to be false, and if it's false, it's going to be true. There's a way of there's a way of writing this to take multiple arguments. Base not doesn't want to do that. Whatever, I won't get into that. So the not function is basically returning the opposite. If it's false, it's telling you it's true.
Do all those functions also work with like inequalities?
Yeah, so I was gonna, that's kind of the next place to go. So, right, so these are all logical statements, so I could say if C1 is greater than, let's just do everything greater than 1. So, yeah, greater than 1, greater than 1, greater than 1, they're all greater than 1, so it's gonna be true. So we can do, there's a couple different ways of writing this. So we can do equals. We can do greater than. Sorry, can you guys see what I'm doing here? Yeah. Hopefully. So we can do, equals, greater than, we can do less than. You can do greater than or equal to. If you want to be inclusive of that number that you typed in, you can do less than or equal to. This, I'm just changing that logical statement right there. And change it whatever we want. So it's, you know, if we were looking at, you know, prices of something and we wanted to, whatever, if we wanted to look at prices that were only over, well, were $6 and over or whatever, we'd be inclusive of that $6 by saying, you know, greater than or equal to $6. And it includes that $6. If we wanted to say it needs to just be greater than $6, right? We don't include the equal sign in our logical function. But yeah, so you can do a logical analysis quite a few ways. The other thing that you can do is you can do things like, if we could make this a little more complex by adding a second function. So I can put another function in here to do my analysis. So if I wanted to take a look at, let's say, the sum of these, well, how about I do the sum of, don't get too complex. I'll do the sum of these, and if the sum of those is greater than 10, it's 15, it'll be true. So it's true. Now, if I said, if the sum is, the sum needs to be greater than 16, it's going to be false because the sum of these numbers is 15. So you can put in, you can do different, you know, you can add in different functions there for your logical analysis. You can do some other things too. We can actually use Boolean functions with text as well. So these don't just have to be numbers. We'll get into a little bit of text. A little bit of text stuff in the if statements here in a second, but I can basically take a look at a piece of text and say like, hey, if this piece of text matches, you know, whatever, some input, that it'll return true. So if, let's say we're looking at like authors of books or something like that. If I want to look at a last name, and if the last name equals something, then the function will tell me that it's true. Maybe let's see if I can do something like that. So let's just type in, or I'll just type in my last name, and I can write. We'll write a not function, and I can take a look at this cell. And I'll take a look if it equals my name, that it returns false. So what this is saying, it is my name. So if I said I'm looking for something else, it's true. So it's not function again. What I'm looking at, it's returning false because it's finding that text that I select. If I look for something different, it's going to return true because they're not equivalent. So the way we search for text in Excel is we put quotes around something that when you want to search for text, which is going to be important in a second when we talk about if statements, but you can use logical functions for text, not just numbers. Questions kind of high level on this, then I want to maybe take a look at a couple of examples. No? Okay. All right, so let's do, what do I want to do here? All right, so let's just take a look at, if you guys can open up Excel, I'd like to just play around here for a second and see if you can write a function. So let's put a couple of numbers down here, so, what do we wanna say? I'll tell you what, let's just go to the, just open the Boolean thing here rather than try to play around with file. All right, let's just go through this. Just a couple here. All right, okay, so we're looking here at some credit application scores. You can see that there's applicant number, credit score, a loan amount, and some payment information, and then some kind of binary logic on they have a savings account and it's on auto pay, right? So we've got a few things that are numbers, right? And then we've got a few things that are text based. So it's asking me to write a Boolean formula that returns true if the payment income ratio is below 43%. So I'm gonna type that into the formula or into the box here. Can somebody give me like what Boolean function do you think we can use to check this? We're only checking one thing. But we want to check to see if the payment income. If the numbers in this column are greater than, or I'm sorry, is less than 43%. So what? Out of those three functions that we took a look at earlier, which one do you think we're going to use to check whether something is true? I'll give you a hint. It could be any of them. But which one should we use? And. Okay. So why do you want to use and?
Just wanna have like C equal, oh, E equals greater than 43, then it's true.
Okay, so we're checking if E is less than 43%, right?
Yeah, that's it.
We want it to be less than, do we want it to be less than or equal to?
That's not equal.
Yeah. I'd say it's just specifically less than because it says it's below. If it doesn't say below or equal, it means it's specifically below. So I'm gonna do that. Does that look right? Yeah. Cool. All right, so that one is less than. So I'm gonna drag this down to the next line. What should we see? What should we see here? So this one's this payment income ratio is exactly 43%. What are we gonna see here? Is this gonna say true or false?
False,
False? Why is that?
because we didn't say equal to.
Okay, so it should be false. If it isn't, we did something wrong. All right, so that one says false. Next one down should be true. Next one down. Whoop. Next one down should be false. Next one down should be true. Okay, so we're just looking at this column, we're doing this and analysis. Now, we're using an and analysis again because we're checking if something's true. If it's right, we want to take a look at if it's true. We don't need, while we can have multiple arguments in our analysis, we only have one right now. So because that one is true, this thing's returning back true. Okay. All right. It's saying, so this next one, calculate down, okay, whatever that means. Use a Boolean function that returns true if the down payment exceeds 10% of the loan amount. So if the down payment is greater than 10% of the loan amount, we want to return true. So again, what function, so I'm checking something, and if it exceeds that, if that the logical statement that I check is true, I want it to return true. So what function do you think I should use here?
Say what?
Another and, okay. And then I want to check. Anybody disagree with that? No? All right, so then I'm checking, I've got my logical statement, and basically what I want to see is I'm looking at the down payment, and I'm looking at the loan amount, and I want to calculate if down payment exceeds 10%. How am I going to calculate that? So I want to see if the down payment amount, which is column F here, exceeds the loan amount in column D here. So how am I gonna calculate if the down payment is 10% or more?
Greater than 10%.
I'm sorry?
Greater than 10%.
So how am I gonna write, how am I gonna write that into to Excel? Yeah.
You get a lot amount times 0.1 is greater than down payment amount.
Okay, so I wanna take the loan amount, multiply it by 0.1. And then I'm checking if that is greater than the down payment. Is that right? I'm taking 10% of the loan amount. If that exceeds, or I'm sorry, I'm taking 10% of the down payment. If that exceeds loan amount, this should return true. What do you guys think? Does that look right?
Would you be the other one? Wait, that is- Wouldn't it be, you want the down payment to be greater?
So this is what it's asking for me. What's asking for is it wants to return true if the down payment exceeds 10%. So what this statement's saying here is if the loan, or I'm sorry, if the down payment exceeds 10% of the loan amount.
So you want the down payment to be bigger.
Right, so
But
what I really want is this.
yeah,
Is that right? Well, let's take a look. Okay, so let me ask you this. On this first one, does the down payment exceed 10% of the loan? It does, right? Because we have got $337,000, 10% of that's gonna be $33,000. We've got $47,000, this is the down payment, right? So this should return true if our statement's correct. So let's test what we got. What we've got is true. Okay, if I had done it the other way, if I flip my sign. That's interesting. Did I not flip my sign? Yeah, I guess I just typed the same one, huh? Okay, so if I flip my sign, it's false, so we know that this is correct because it's returning true, and we know this one should be true. All right, are we good with the analysis on what's going on there? No. So what it's saying up there is it's going to return true. And what the AND function does, remember, if the logical statements are true, so if this is correct, what the AND function does, it returns, meaning what it's going to put in that cell, it's going to return true if that logical statement is correct. Okay, so what we're looking, we want, if that logical statement is correct, we want this function to return true. So we're trying to write a statement where we appease what they're asking us for, and when those statements are, and write a statement that does this analysis. So what it's asking, right, is it's having us look at the down payment, and if the down payment, which is this column here, if this exceeds 10% of this column, then this logical statement is true. Okay, so that's the analysis that we're doing. So we want to write a statement that compares these two columns. And that's what this is doing right here. So we're taking 10% of our loan amount, and then we're comparing it to our down payment. And the only real question is, okay, so I got it. We're comparing 10% of the loan amount to our down payment. What's the right symbol, basically? What do we want? And that's what we landed on. If the down payment is greater than this number, that's what we want, meaning that's correct, and therefore that will be true. Is that, I mean, I'm sorry if I didn't mean to, like, I don't know if that broke it down like more simply or not, but you get what the analysis that we're trying to do at least? Okay. All right, so if I copy this down, this one looks right to me because it should be like 25,600 in order for it to be 10%. It's less than that, so that looks correct. This one is more than 39,000, so that looks correct. So looks like we did that one first. All right. So it's going to say, okay, so calculate score okay using the not function. Return true if the credit score is not less than the threshold credit score. So you see we've got threshold credit score up here. We've got our credit, the rest of our credit scores down here. So we want to return true if the credit score is not less than the threshold credit score. So we're going to use the not function because it told us. So that seems pretty easy. Somebody give me, like, what do you think? What do you think a logical statement here would look like? Anybody got a guess? Yeah.
C12, like not C12 less than 650. I mean, clicking on.
So you're taking a look at T12 and you're checking if it's, sorry, was it less than?
Yeah.
Checking if it's less than threshold. That. Yep. Okay, so let's take a look at this. So we've got a not statement. So that means not statement means if this is false, it's going to return true. Right, it's opposite for some reason. So we want to return true if the credit score is not less than the threshold. Right, so it's a credit score So take a look at the credit score. If it's not less than F9, we should threshold score. This should return true. So I think that's right. But I don't know if that's. All right, let's read this again. Turn true if the credit score is not less than the threshold. It is less than the or it's greater than the threshold, so it's not less than the threshold. All right, that's correct. It's a mouthful. Not functions are they're confusing because it's what you're doing. But does that make sense? Though this is not less than this, and therefore this is true. So that's what it's asking. I know that's like a little confusing. That's what the statement's asking for. It's saying, is 658 not less than 650? And if so, it's true. All right. Sure, we've all got it. All right, I'll go on to the next one. Calculate approved, use the and function, return true with payment okay. Down okay and score okay. Okay, so what we're doing here is we're going to take a look at these other three columns and create a logical statement based off of these three columns. So we're going to we can use the and function here because I'm looking. What this is asking me to do is look at these three columns. And basically, if these three columns are true, it's approved. If they're not all true, then it won't be true. Okay, so I'm looking at those previous three and trying to write a function that takes a look at each one of the three columns. If all three of them are true, the whole thing is true. Can anybody give me if I want to take a look at these three columns, what would it, can you give me a logical statement of how I would look at this value in the payment okay box and see and test if it's equals true? Anybody got an idea? We're going to want to look at text. No ideas? Nothing? Where would you start? Is this the most boring thing possible? Did I lose you? What do you got? Yeah.
Take each or insert like what's that, I-12. And then equals true, that's like the first one.
Okay, so I'm gonna take a look at I-12 here. Equals
True.
okay, and I'm gonna write true. Like that. Okay.
And then your next claim is J12 equals true.
Okay, same thing.
And it's same thing for K12.
Let's take a look at that does. It's already true. It's down. See that these are all false because they don't have truths all over the promise. Okay, so again, we were setting it to that condition. So yeah, we just took a look if it was true. The reason we didn't have to use quotes around these because these things aren't actually text. It's a Boolean function, so true is like a value. That's why we're just searching for value true. So I showed you those like changes around text. These things, since it's a Boolean function, it's text. I know it appears as text, but Excel doesn't treat it as text, so we don't need to use notations. So basically what we did is we built a function that's looking at the logical analysis of these other three columns. Then we're doing kind of an analysis on that, saying, hey, if all three of these are true, return back true. Alright, let's do this last one. So we want to calculate discount using the OR function, return true if either savings account or auto pay is listed as yes. Okay, so in this case, if I come into these things, you can see that these are actually text. So if I clicked on one of these, this is a function. And it's showing up on my screen as true, but it's not actually text. But if you click on what it is, it actually is text up there. So we're going to use the quotation. So we're going to take a look at text. So it's telling me I'm going to use the OR function because if either one of them is just yes, I want it to return true. And I'm going to write a couple logical statements. So can somebody tell me what am I gonna set my savings account equal to? Check that text. That. You guys remember Alright, so I do a quotation, I do yes. Then I'll do another logical statement for looking at auto pay, and I check if that is equal to yes. Because if this is an OR function, if either one of those is correct, it's gonna return true. So this next one, since they're both no, it should be false. One yes, there's two yeses, so the rest are returned. Alright, so that's how we're checking. Again, that's how we're checking text, that's how we're checking using an OR statement. Hopefully that. It's clear as mud, huh?
Why didn't you use quotations again?
Because I'm looking at, I'm checking this text, so I'm saying, is the text equal to yes? And so when I look at text, I need to put quotations around it so that Excel knows it's looking for text. Okay, I'll show you. So if I didn't do that, so if I just did this. Sorry, I know I'm off to the side here, so it's not looking. But if I take away these quotations. Gonna give me an error, okay?
You think you can go back to the one?
This one? Yeah, so you can see so the reason we didn't use quotations here again is because while these, I mean, I know it says true here, but if you look at the
That's part of the function, so like.
right, if you look at what's actually like in that cell, it's a function, so it looks like text, but behind it's actually not text, so this doesn't treat like text. Does that make sense? Yes, no? Questions on Boolean functions? Everyone like knots? That's super exciting, right? Generally, like generally the test, I don't think it's asked really, it's usually asking an and or an or function. It doesn't really ask knots, and the language of knots you get really confusing. Generally it's gonna ask an and or an or function. This is pretty close to what it'll ask you though, like doing this type of analysis is pretty on point for things here. Yeah.
So I should ask, do these also work if I like highlight and get a range, multiple range too?
Yeah, so like give me an example of what
So like for the approved column,
yeah, so if I like okay, so okay. So you're saying if you do like so if I change like the second one, it's like a range like this, like that. that, yeah. So, yeah, it doesn't, like, it won't, doesn't do that analysis.
For mine, I did I-12 to K-12. So the first,
So did. You hear?
I-12 to K-12.
Is that? Sure. Like this?
Yeah.
And you getting an output?
Yeah. But I didn't type it, I just like randomly. So like I.
Show me what it.
And it came back as true?
Yeah, for even for like the discount one, I highlighted these two. And then I just like reput it.
I wonder if I don't know, let me see if I can try doing it. Yeah, I don't know, maybe, you know what version of Excel, you might be using a newer version of Excel that handles that, I'm not sure. Yeah, I don't know, it's not liking my range. Yeah, I'm used to doing that. You can do, like, if you're even doing sums and things like that, like I'm seeing ranges, but generally I. More discrete, yeah. All right, any more questions? Good, Boolean? Yeah, if you like that, you're gonna love if statements. On this. Okay, so, does anybody know what an if statement is? An if then statement? Any like quasi programming people? Yeah? No? So a couple heads shake, perfect. I assume everybody knows everything about it. So an if statement, what an if statement does is an if statement is gonna basically, we're gonna perform a logical test, just like we did in Boolean functions. So then it's gonna allow us to do some things that if the value, if our logical test is true, do this. If not, do this. All right, so we're able to write logic. Doing some analysis, and then depending on what the output from that analysis is, do something else. So for instance, if I say if the sum of these numbers is greater than 25, I'm gonna have it say greater than 25. And if it's not, I'm gonna have it say less than 25. Right, so I just wrote a statement that's taking a look at the sum of the numbers like I have up there, it's doing a logical analysis on if they're greater than 25. If they are greater than 25, it'll print this statement, and if they're not, it'll print that statement. So I think these numbers should be greater than 25. That's what it should say. It's greater than 25 in that column, right? So I need to focus on that text because I wanted it to print text. Did the analysis if I didn't have those quotes. Just this. It's not gonna like it. And so need to add. Need to add those quotations in.
So are you asking it to tell you whether it's greater than or less than 25 by the using the F function?
So what the if function that is doing is, what I'm doing is I'm doing an analysis. And so this is it's a logical test. So I'm doing this logical test and then if this logical test is true, do this. If it's not, do this. Now, when I say do this, what the do this thing is in this statement that I wrote is put on the screen greater than 25 or put on the screen less than 20. Now you can imagine, let's say I had like a bunch of columns and I was doing this analysis like multiple times. You know, let's say there were 100 columns and I wanted to check which ones were greater than 25 or less than. I could write this once and then I just, copy the statement across all of them and so it, on this one little column of numbers, it's not very powerful, but if I had a lot of data and I'm trying to do a lot of kind of analysis, just copy the formula. Yeah. So what's interesting about this is I can start adding more interesting things. Well, I can do more interesting logical tests. So what I call the same stuff that we just did on Boolean as far as logic tests. But then I can do different things in these areas too. So the value of true, I can actually put another if statement in here. And if this is true, do another if statement and check that out. And do that analysis. So we can start building like if statement trees. I can start do a bunch of kind of complex analysis and then, ultimately tell us something. Yeah, so that's the basic for how a if statement works. Again, we've got a logical test, value true, value false. So so I can do something, let's do something else here. So I'll just do the same analysis. And I'll say if the value is true, not coming up with anything good. No, if the value is true, I can try to add something to the number, but no, I'm not doing. I got lost in my own thoughts. This is what I'm trying to do. I don't know what I wanted to show there. Nothing important. All right, let me before I lose everybody because of me not having my thoughts together, let me get into like a nested if statement. So here I'm taking a look at, I've got my if statement, I've got my logical test. And then if that's true, I'm gonna actually put another if statement. So now I've got another if. So again, this is in the value of true of the first if statement. I've got a second if statement. I'll do another logical test. So now I can do like, let's check column. Do another couple numbers. Sorry. So I'm checking that first column. If they're true, I can do another if statement. And let's say I'll check this second column. And I'll check if those are greater than 25. So then I've got a value if, so then within this statement, I can have a value if they're true. So if the first one's true and the second one true, we can say both columns over 25. If the first one's true and the second one's false, so if this one was true, that means I'm in this statement. I'm typing in this value of false, so that means if the first statement's true, the second statement's false. It would be like, my statement would be something like, column 2 only. As far as what's over 25, so whatever, column 2 only. Then I close this if statement because I've got my logical test, I've got my value of true, I've got my value of false, so I close that logical statement. And now I'm gonna write the last statement here, which is the value of false. So if this first one is false, if the first column is false, I'm gonna say column 1 not greater. Something like that. So I'll like go through this. Tell you what the heck we did here. Okay, wrong.
Parentheses.
Should be fine. Okay, let's see. What the heck did I do? Oh. Just this, that's. Sorry, right. Alright, sorry, I didn't say so. Okay. Alright, so let me take a look at this. So here's the statement I wrote. So I've got an if statement. The first thing I'm looking at this column B and I'm checking if column B is greater than 25. If column B is greater than 25, I'm moving to this value of true, and that value of true is this second if statement that I've got here. All right, so if this is true, I'm doing an analysis here. Now within that if statement, so again, once I've got the values true here, I'm analyzing here. First thing I'm doing is I'm looking at column C and I'm saying is the sum of column C greater than 25? If that's greater than 25, I already know this one's greater than 25 because otherwise I'm not doing the analysis here. So this is true and this is true. So if this is true, then I'm going to the value of true here, and because of that, like because I'm doing this analysis, I know that both columns are over 25. That didn't make any sense, did it? All right, how do I simplify what the heck I'm trying to say? All right, between here and here, that is one statement. That is the value if true of that first statement that I made. All right, so if you see these three commas, there's one comma here, and there's one comma here. For my first if statement, that's my logical statement. That's my second value of true, and that's my value of false for that first if statement. Is that clear? Yes.
Why do you have two values if it's true?
I don't have two values if it's true. This whole statement is my value if true. That whole statement. So I have a whole if statement nested into the value if true.
And the answer, if it's true, it's both columns were 25 and column 12.
Say that again.
Like, I don't understand why you have two quotation marks. You know, like
Yeah, so these are like you're saying like these quotations.
that one, one to the right,
Okay, so
inside the parentheses.
okay, so on my first logical if statement, here's the right between here, that's the logical test, right? Okay. So let's say if this is false, let's just say this statement's false. If this statement's false, I actually come over to here.
Yeah.
Because this is the value if false. So if this is not true, I'm coming all the way over here and it's the output of this function is gonna say column one, not great. Okay? If this statement is true, I get the value of true, which is this second if statement, and now I start doing another if statement analysis. So in this, and once this is true, I'm coming here, and then I'm saying, oh, okay, well, let me do a second if statement analysis. Is the sum of this column greater than 25? And if it is, I go here. And if it isn't,
I get.
I go here.
Okay,
Okay?
perfect, thank you.
I like, is that clear-ish?
Yeah, that was a little better.
Okay.
Yeah.
Okay, but so that's what. Like, so there, when I say the nested if statements, just remember, like, each if statement has three pieces. But then within the if statement, I can kind of expand it out. So I could have had another if statement over here on the value of false too, and done another analysis if the value is false. So you basically can build an if statement tree to infinity. I mean, it's a lot closer to programming than kind of anything else in Excel. You know, I could have another if statement here that if this is true and this is true, then do another if statement analysis, and you can keep kind of building on things like that. There will be an if statement. The reason, like, I'm spending time on this, there's usually a nested if statement on the loss exam, like pretty much guaranteed. It's usually not like super crazy complex, but they do ask you to do this type of analysis where you're gonna wanna take a look at a couple different like columns of data, and basically they're gonna want you to generally kind of the way things they use these statements is like finding some. You take a look at the values if my first statement was like, if the values are greater than 100, and then my second was to one, or they're. I'm not doing a good job here. You basically can use this to find if a number is between, like, two other numbers pretty easily. We'll get into it in the homework examples, because that's kind of what they get into showing you, but these are good logical statements for figuring out if something's kind of in between two things. It's a long-winded way of saying whatever the heck I just said. All right, so that's how nested if statements work. What questions do you have? Nothing super clear.
Yeah.
So next class, I'm gonna hang on this for probably a class or two, like this area, because I think this is probably the most confusion in this area, and that's just because of my teaching, but it is more confusing because we're dealing with logical statements.
Yeah.
And like it gets kind of complex. So I'm gonna go into more depth on this next class and probably spend some time actually going through homework problems. Yeah, I guess I don't really want to open up a new topic. We're just gonna do that next class. I guess is there anything I can answer before? Yeah, like you guys see. Okay, I said this, not everybody was here, so on Wednesday, we're gonna move the class, starting Wednesday, it's gonna be LC 106. So I'll look at an announcement on the canvas, but, don't come here anymore, we're gonna be going up there.
Thank you.
Yeah, sorry I couldn't do it this class, I didn't get word until earlier today, so I just decided not to do it. Okay, well, hopefully I didn't totally confuse you. I promise it will get, like, this will make sense once we go through it. You will work in problems. So if you're lost right now, don't worry about it, like, it'll come together. Thanks.
Thank you very much.
See you next class.